Well, good morning, ladies and gentlemen. It's a real privilege to join you this morning, albeit virtually, and to give the first presentation in this morning's workshop. My name is Stephen Meers, and I'm the head of the AI lab at the Defence Science and Technology Laboratory here in the UK. And I hope this morning I can give you a slightly different perspective on the challenges of operationalising socio-technical systems into defence. For the past 15 years, I've had the privilege of being a scientist working at the heart of the MOD, trying to take S&T from the laboratory into operational use within the UK Armed Forces. Some of the time I've had the privilege to be part of a team that has delivered really successful outcomes and really enhanced UK capability. Other times a seemingly good idea has been consigned to the valley of death. And I hope this morning I'll be able to cast a little bit of a light on those two situations. So first of all, I'll just share my screen. Okay, so before I start, I'd just like to introduce those of you that aren't familiar to DSTL to what we do. We are the science and technology organisation within the Ministry of Defence, and our work supports the breadth of requirements across the MOD, but also the security services, the other government laboratories such as Public Health England, who we're currently working closely with on the COVID crisis, and also the UK Police. We're not a very well-known organisation, but our work has real impact both on a national and an international stage, whether that's the 500 tasks that we're currently running as part of the government response to COVID, whether that's the critical work that we played a couple of years ago in the response to the Novichok poisonings in Salisbury, or whether it's the fact that we were the largest deployer of civilian personnel to Afghanistan during Operation Herrick, supporting our armed forces. So DSTL really is quite a unique organisation. Our position at the heart of UK government means that we can really apply S&T where it can make a real impact. So part of DSTL's role is to advise MOD on the future emerging technology trends and what the opportunities and the threats that those trends will present to the MOD. We see AI as one of the most transformative national security technologies that will affect defence and security business over the coming decades. We think it's going to be a ubiquitous, enabling technology that will affect everything from the back office to the battlefield, from the private to the general and the National Security Council making strategic decisions. However, distinct from previous transformative technologies such as flight and computing, we think AI could be the first example where we see what you might call a real ethical differential in terms of the models of adoptions that different nation states, different actors such as terrorists and insurgents and pressure groups or extremist groups, and how all of those different people may choose to adopt AI in different ways. So for us, it's really critical that the UK and the Western nations show real leadership in terms of responsible adoption of AI in the defence and security arena, that we show high moral and ethical standards and really help establish and reinforce effective international norms for the use of this technology for defence and security purposes. So within DSTL, we're exploring a range of different use cases for how AI could impact on different defence tasks. You can see some of them on the screen here. I'm not going to go into these in detail, but I'd just like to illustrate the kind of work that we do through 3 case studies. So the first of these case studies is looking at the role of AI and autonomy in the tactical logistics support. So a real challenge for the logisticians working in defence is what they call the last mile resupply. This is by far the most hazardous part of the logistics enterprise, and it presents real challenges to operators. And actually in Afghanistan, this was where a lot of the UK injuries and fatalities did occur as we attempted to resupply our forward operating bases. In this challenge, we've been working between DSTL and the US Army Research Labs, and we've been undertaking a 4-year collaborative program looking at how autonomous vehicles, such as self-driving convoys of trucks, as well as delivery drones, can be combined with the back-end software and planning tools in order to help us keep frontline forces resupplied. As part of this work, we ran 2 major field trials, one on Salisbury Plain and one on the Western Test Ranges in the United States. And we're able to show a viable operational capability that is now beginning to be exploited by the Army here in the UK. A second example is that of predictive maintenance for the Royal Navy. Here we worked with a team called Program Nelson, who is the Royal Navy's Agile DevOps team. And with them, we looked at the sensor systems on the Type 45 destroyer. On one Type 45, there are over 4,500 sensors that monitor the turbines, the diesel generators, etc. And we're able to gather the data from those sensors and use that to provide a decision support tool to the engineers that work on the Type 45 to allow them to assess a particular fault or failure, and also to spot potential faults and failures before they happen and take remedial action. So you can see the decision support tool in the bottom right hand part of this slide. And this tool is currently at the beta stage and is currently undergoing some at-sea trials on HMS Defender. So the third example I'd like to give you is one of an autonomous sensor network we've developed called Sapient. This is an open and modular architecture that allows a number of autonomous sensor systems to fuse their output and to use that fused output to reduce the cognitive burden on a human operator. So we originally began this work working with the Department for Transport, looking at secure perimeters. For us, it was base protection. For DFT, it was looking at cargo and shipping containers. But since then, we've been able to build on this work to look at urban operations, and this work has been trialed in Toronto, in Canada, and will be trialed in Portsmouth in the UK in the next few months, COVID permitting. And then we've also been able to look at it for counter UAS scenarios, such as we saw at Gatwick a couple of years ago. So again, another successful piece of work where, again, we're working with the Army to exploit this into their future integrated tactical ISTAR equipment program. So why have I shown you these 3 capabilities? What do they all have in common? They've all been able to exploit some real innovative research. We've been able to get really good teams of scientists and engineers together from industry, from academia, and from government. We've been able to run experiments to show how these capabilities might generate military benefit. But the one thing that unifies all 3 of these is that none of these projects, despite all the promise that they show, has yet been able to make the transition from an experimental system to an operational capability. This is what I like to call the AI paradox. So the AI paradox says that it is deceptively easy to launch AI pilots with initially powerful results, but at the same time, it is fiendishly hard to deliver those solutions at scale across a large enterprise. So in stating this, I'm in no way seeking to denigrate or undervalue all the hard work that goes into AI pilots. I've been involved in a number myself. I realize how hard it is to deliver a really compelling demonstration and experiment. But what I'm trying to draw attention to is what happens at the end of the pilot. All too often we see scientists and engineers feeling that their role comes to an end at the end of that pilot period. And we then see real challenges in terms of overcoming the big organizational barriers to really adopting this as an operational capability. We've spent some time just trying to study those barriers within DSTL, just to try and allow you to see all of those different barriers on this screen. And there are some really challenging issues that present themselves. the availability of the data, the quality, the sustainable data platforms and the standards that underpin them, the ongoing process of building user acceptance and trust, the assurance and certification of capabilities, which in a military environment is a particularly important issue. So I won't go through all of these, but you can see the broad range of organizational issues that need to be addressed in order to transition an AI or data intensive system into operational use within the MOD. Now, to help our scientists and engineers respond to this, we really believe that a socio-technical approach is at the heart of this. And actually, our experience has been that where our project teams have been able to bring together the combination of skills and experiences, the multidisciplinary cross-functional teams, that's delivered far better outcomes for our S&T work. So to guide this work, we've developed a framework that we call the AI building blocks. And this is designed to guide the scientists and engineers and to help them consider a AI or data intensive system from a number of different socio-technical perspectives. These building blocks come into three types. The first type we call the systems building blocks, and these start with advantage, really focusing on the end user of the capability, understanding the problem that they problems that they are faced with, the requirements that they have, how they work, and really asking some quite challenging questions about how AI and data systems can really benefit that user. It might be that in a lot of instances, AI and ML is a sledgehammer to crack a walnut. There may be much simpler, more effective systems that can be put in place. So the point here is to start from a deep understanding and collaboration actually with the end user of the system, and really make sure we understand how we think this kind of intervention, whatever it is, might help. The second building block is consent. Just because we can do it, should we do it? So this is understanding, is it legal? Does it fit within our existing legal frameworks? Is it ethical and responsible? And also, does it fit within MOD's policy and risk appetite? Then the third system building block is one of confidence. So this is really about building trustworthy human-machine teams, understanding the safety arguments and considerations around deploying a system into military use, really understanding how we can assure that system and ensure it's resilient, not just in a benign environment, but in a denied and degraded environment where that system may be under adversarial attack by some kind of enemy force. So around the side here, I've just given a kind of an illustration of some of the activities that DSTL are currently involved in that relate to these different building blocks. I won't mention all of these, but just to draw your attention to a couple, we are working with a number of different innovation units across defence through an initiative called Prototype Warfare. And increasingly, we're seeing kind of agile DevOps teams working very closely with end users, trying to operationalize these technologies. The other one I'd like to draw your attention to is the safety assurance objectives. If you are interested in how we assure and certify autonomous systems, I'd really recommend this particular publication, which was by the UK Safety Critical Systems Club. DSTL had a very strong input into this, which has really, I think, been some world-leading work on how to assure autonomous systems for safety cases. The next set of building blocks we call the technical building blocks. This combines ensuring that the team are thinking about the data they're going to be using, they're understanding the quality of the data, the format, its availability, any sensitivities around its use, what privacy issues there might be, as well as what biases we might expect to see within the data. Can we assess the data for bias using different kind of testing combinations, and also the provenance of that data. That then leads into the algorithms and really ensuring that we're rigorous in selecting the right algorithm for the job, that we're understanding how effective that algorithm will be against our particular use case, what the limits of its performance are, what has it been trained on, what is a reasonable expectation for what that algorithm might be able to deliver. Another significant issue for defence, and this is particularly because of the nature of the work we do, the security, but also the forward deployed nature, where we're often working in denied or degraded environments where you can't rely on good comms, is the platform that all of this is built upon. The combination of cloud compute, on-prem, and edge AI solutions that give us robust performance in degraded environments. But as well as that compute, the architecture that compute exists within, the interfaces, the standards, and then finally that the integration of those three things into a system and the system of systems, how that integration both between the human and the machine, but also the machine to machine interoperability can be designed. Too often we see stovepipe solutions within defence that perhaps work well in the particular scenario they've been designed for, but that don't achieve the interoperability that we need for joint operations or for coalition interoperability. So a really important consideration. And again, here's a selection of some of the research that is going on. I'll just pick two in this instance. The first is we're very interested in synthetic data generation. A lot of the data sources that we work with in defence are quite sparse. We don't have many examples of the kinds of particular platforms we're interested in. So synthetic data generation can help us overcome that challenge. But then also model cards. There's a link to a recent paper from Google that is talking about the approach that they've been taking, trying to document the performance of the different machine learning algorithms they've been developing, and we're absolutely looking at how we can adopt that in defence. Then the final two building blocks are the organizational building blocks. The first of these is expertise. Getting access to sufficient, suitably qualified and experienced machine learning engineers and data scientists is, as you know, a big challenge for all kinds of different employers and organizations. So for us, we're putting a lot of emphasis into learning and development, reskilling our workforce, retaining the talent that do have, to make sure they've got really rewarding opportunities, but also the diversity that we're able to build within the workforce, the teams that we're working with. Not just gender and ethnic diversity, but also neurodiversity. So within DSTL, we've really got a long way to go, I think, but we have made real progress, I think, and we've got a lot of support mechanisms now to make DSTL a really diverse organisation, both in terms of some of the support we provide for our neurodiverse workforce to allow them to really maximise the contribution that they can make. I think the ethnic diversity of the organisation is increasing as well as the gender diversity. So, for example, in AI Lab, where I work, the three other senior leaders within the AI Lab team are all women. So that's a really positive indicator, I think. So as well as the expertise, we also have the enterprise. So here, this is the much broader issues around this organizational strategy and governance, the financial and commercial frameworks, as well as the agile acquisition techniques that are needed in order to bring these kind of rapidly changing technologies into operational use. And again, here's a range of the different initiatives that we're currently working with. I've just mentioned two here. We've recently been part of the Trailblazer group, has successfully managed to establish a new national standard for master's level AI apprenticeships. So we think this is a really positive step, and we're hoping that a number of universities and learning providers will now start developing offerings against that apprenticeship standard. And then on the enterprise side, we're really pleased that as a result of an internal MOD review, a new defence AI and autonomy unit has been stood up within head office that is now responsible for coordinating all of the policy work on AI within MOD. This is a really valuable organisation, and you may have noticed on one of the previous slides, they've been doing some work on now trying to formulate a formal ethics framework for UK military adoption of AI. So I hope that gives you a sense of the approach that we're trying to take within DSTL and MOD in relation to AI. We're very much looking for external validation of the building blocks approach. So I'd be grateful if you do have views on this. May well come up in discussion and Q&A later on this morning. But equally would very much welcome any input to AI_lab@dstl.gov.uk. And this is increasingly being used as a framework for our scientists and engineers, our S&T planning and commissioning function, our policymakers, as well as program managers and the military desk officers across MOD. But we're now trying to underpin these building blocks with a set of best practice guides that will provide more detailed advice on the specific considerations in each building block. So just in summary now, the key messages I'd like to leave you with are that we absolutely recognise the transformative potential of AI, both as an opportunity to enhance UK armed forces and keep our people safe, but also as a threat where we need to understand how we can counter AI threats to the UK and how we can help stabilise the overall kind of global geopolitical sort of situation for AI. However, as I've explained, one of our real challenges is in this kind of AI paradox, which is limiting the pace of change that we can achieve. So for us, this socio-technical approach that we're talking about today and that I've described is a real, has demonstrably shown how we can achieve better outcomes against the barriers I described. And our building blocks, finally, are the structured framework that we are using to try and help our scientists and engineers and wider decision makers take a socio-technical approach as we develop AI systems within MOD. Thank you very much for your attention today, and really happy now to take any questions. Thank you.